Thanks for joining my lightning session. I'm Tim van Baarsen. I'm working at ING in the Netherlands, and I'm working in the investment tribes. And today I'm going to share you nice lessons learned about Kafka that we're of course using at ING. So really quickly about Kafka at ING. I think we can say we are front runners in Kafka. We are running Kafka in production for over 6 years. And the last couple of 3 years, we are using the Confluent platform. We are running almost 2,000 topics in production. And yeah, Kafka is basically used and serving more than 400 development teams within ING. Over the last couple of years, the traffic grew quite enormously from 20K messages to 350K messages per second, and still counting, right? It's still going up. There are many different use cases with Kafka within ING, and we also serving, basically self-service management on topics for all the Kafka teams. Just to be clear, I'm not a member of the Kafka team itself. I'm just a user of the Kafka cluster in ING. But those are some impressive numbers to share with you today, to give a little bit of context. Like I mentioned, I'm from investments. We are using Kafka for more than 3 years in production now. We learned a lot of things along the way, right? After the honeymoon phase is over, you will run into some traps, some lessons learned, and that's what I'm actually going to share today with you, so you can apply this in your own project. And you can, of course, share this with your fellow developers. So the agenda today is basically about poison pills. It's about deserialization exceptions. So that's the lightning talk today. I will sum up with some lessons learned, and there is around 5 minutes left for questions at the end of the session. Because I have a lot of ground to cover, let's get started. I'm from investments. It's a quite complex domain, so I don't want to overload you with a lot of domain lingo, but the only thing you have to remember is that if we talk about a quote, it's basically the last price on a stock quote. So we have, for example, an Apple stock. It's traded on the stock exchange. At some point, the price will go up and down, and there is a new price. And in this demo, we are going to produce a lot of price updates on stocks. And we're going to look into deserialization exceptions and how to handle them. So let's dive into poison pills, deserialization exceptions. What is it actually? A poison pill is basically a record that is produced to a Kafka topic, but cannot be deserialized by the consumers. And it doesn't matter how many times it's attempted, it will always fail. And this is, of course, can be quite a big problem, especially when you're running and hitting this in production. So a poison pill can basically come in different forms, right? It can be a corrupted record. I never encountered this myself. But the most common way to encounter this is a deserialization failure on the consumer side. Let's go to the next slide to give you a little bit of context. So in the demo I'm going to run, I'm a consumer of this data, the data that's on the Kafka topic. And at some point in time, somebody else is producing data to this topic that it's not up to par with the Avro schema. And this producer is not using Avro at all. So it will just publish this data to the topic. So let's take a look. One of the producers is just producing, of course, raw data. So there's an Apple stock coming in, a price update there, also an ING stock. And at some point, somebody is producing some poison pill onto the topic. At that point in time, the consumer will basically fail to deserialize this message. The impact is quite high, and the consequence is that your consumer will try to deserialize again and again, very fast. And for every failure, it will basically log a line in your log. And the nasty thing here is that basically the consumer cannot swallow that poison pill and cannot move forward. So it cannot automatically set the consumer offset forward to skip this poison pill. Yeah, so I mentioned the impact is quite high, and if you're unlucky, basically you can flood your disk if you're not detecting this scenario. So I saw this happening in quite a lot of projects, and people always struggle with this kind of situations. So what I saw people doing to survive the scenario. Some people waited until the retention policy on the topic passed and started to consume from that point on. So then the poison pill was gone from the topic. But of course, this is not really a nice situation you can do in production. I saw also people changing their consumer groups and start consuming from basically the end of the topic. So they also basically sort of hacky skipped this poison pill. I also saw people manually or programmatically updating the offset. That can work, but it's still a bit hairy to do. Since we are using Spring Boot for our microservices, we're also using Spring Kafka. And Spring Kafka has a really nice error handler deserializer that you can really easily configure in your application to survive this scenario. So in this demo, I'm going to show you how that works. So I'm first going to basically cause a poison pill scenario, then fix it and show you how you can actually do it. So really quickly, you might notice, but as long as the producer and the consumer are using the same serializer and deserializer pair, everything is fine, right? The producer is producing data. It has a serialization class for both the key and the value. The broker itself, the Kafka cluster, is not responsible for doing any type checking, schema validation, or other constraints. The data on the Kafka topics are just bytes. And those bytes are consumed by the consumer by polling. And as long as the serializer and deserializer are compatible, basically, then everything is fine. But in case the producer changes the serializer, or somebody else is producing data to your topic with a different serializer, then the consumers will have a big problem because they are not able to deserialize the incoming message from that Kafka topic. And then we will basically end up in this scenario. So for the purpose of this demo, I have this set up for you. I have two Spring Boot applications. One application is a producer that's producing to the topic, and we are producing stock quotes to mimic the stock market. And we have just one consumer consuming the data. They're both using Afro with the Confluent schema registry there. And I am going to basically produce a poison pill to the topic, and we will see what happens then. And at the end of the session, we are going to fix that, and I will share you some lessons learned. So let's head over to the demo, and I will show you some code. Let's get started. Okay, let's head over to the code base. I'm already took the time to start up Kafka. I'm running this in Docker, and I have two Spring Boot applications for you to start. So let's quickly start a producer here. This producer is mimicking the stock markets, as I mentioned before, and it will start producing some data to the topic. There it is. And let's also start the consumer. So here we see we are already producing some stock data to the topic, and let's quickly head over to the view here. So here you see a view on the Kafka topics. This topic is there, it's producing, and the consumer is just consuming the data. So far, so good. Everything is running fine, so let's deploy to production, right? But what happens if somebody else is producing data to the topic with a different serializer? So in this case, I'm using the Kafka console producer. This producer is not using Afro at all, so it can still produce data to the topic in this setup. So let's publish this poison pill. I already feel that my machine is getting a bit sluggish here, and you see the consumer application is now basically consuming this poison pill that we just here produced to the topic, and it cannot deserialize this message. So you will see really fast it will try again and again. Yeah, so let's stop it here to not write too many stuff to the log. And just to make sure that that I don't trick you, right? I just stop the application. If I start it again, of course, the consumer offset will still be at that point of the poison pill. So restarting the application doesn't help here. It will still hit that poison pill. So it will start up again, it will rejoin, and here again we have the poison pill. And this will stay there. So now I just showed you how to basically cause a poison pill. And now, because this is Spring Boot and Spring Kafka, we can basically leverage the error handling deserializer from Spring Kafka. And instead of our serializers here, right? So we have a string deserializer for the key and a Afro deserializer for the value. We can hook in this error handling deserializer. And of course, we still have to tell Spring Kafka what the actual deserializers are that it's going to delegate to. So if an exception happens here, then the error handling deserializer can do something with that exception for you. And what we can do by default, and that's what I'm going to show you here, we can basically say, okay, we would like to log this poison pill and just move on. So yeah, you see with a couple of lines of code and configuration, you can protect your application against a poison pill scenario. So we just did that. Let's start again and see how it works. So the application is the consumer. Of course, the producer is still producing data, right? It's not aware of its consumers. And here it is, it's starting up again, and I have to be quick because we're producing still some data. Here you see basically the poison pill is getting logged. The consumer offset is moved on. And here it's consuming as normal. So it will not stuck there on the poison pill, and you basically survive this poison pill scenario. So really leverage a Spring Kafka's error handler deserializer in your application. If you're interested, because in many cases maybe just logging the error is not good enough, you can also configure a seek to current error handler in combination with a dead letter publish recoverer, and it basically allows you to send this poison pill to another topic that you can inspect later, so you don't lose that message. And here you see a screenshot of a poison pill that's produced, is handled by the application and also produced to this dead letter topic, and that's really awesome. So within a couple of minutes, you can protect your application against this really nasty poison pill scenarios. That's it for the demo. So let's go back to the slides. Okay, let's wrap up. Let's go to the lessons learned. As a consumer, please always expect the unexpected. I hope you don't ever encounter a poison pill scenario in production, but leverage Spring Kafka's error handling deserializer to protect your application against those scenarios. Think about proper exception handling and leverage the dead letter topic mechanism if you need. As a producer of data to topic, always think about your downstream consumers in terms of serializers, so don't change them. If you're encrypting the data that you publish to a Kafka topic, also think about if you're using shared secrets to not change that secret without start publishing to a different topic, right? Because also then you end up in a poison pill scenario if you change those shared secrets. And leverage the Apache Afro and the Confluent schema registry to basically create a contract between the consumer and the producer of your data. Also think about security. Who can produce data to my topic and who can basically consume this data? Those are our lessons learned from our Kafka use cases in ING. Yeah, and then we basically have 5 minutes left for questions, so feel free to ask your questions. Yeah, it was really nice. Thanks for joining my talk. You can scan the QR code to basically check out the complete code base that I used during this demo. So you can play around yourself with a code base, share it with your colleagues, and bring your applications to the next level and protect it against those poison pill scenarios. Thanks for joining.